Welcome to the Explainer. Today we are putting on our scrubs, so to speak, and dissecting the Cambridge Computer Science AS and A-level syllabus. We are going to be zeroing in on immediate addressing, specifically within Subject Code 9618, and we're going to do it with absolute surgical precision. Look, we aren't just here to recite facts at you. We are going to completely break down exactly how examiners want you to think, how they want you to structure your thoughts, and how you need to deliver your answers to get maximum points.
To really understand why we're focusing so intensely on this one specific area, consider this. Did you know that this single topic of immediate addressing accounts for approximately 15% of your total marks in Paper 2? Yeah, 15%. That is a massive, massive slice of the pie for just one conceptual area.
So, you really have to ask yourself, are you leaving 15% of your Paper 2 marks just sitting there on the table because you haven't totally mastered this specific area? Getting this right offers a massive return on your study investment. The absolutely crucial point here is figuring out exactly what the examiners are actually looking for so you can claim every single one of those marks. It's all about working smarter, not just harder, right?
Okay, let's dive right into Section 1, Core Theoretical Foundations.
We absolutely must start with a precise definition. Immediate addressing isn't just a vocabulary word you can cram into your head the night before the exam. It is a fundamental addressing mode, and it demands logical, structured reasoning. Examiners are actively looking for precise definitions, rather than just, superficial breadth. They don't just want to know that you've heard of the term. They expect a deeply connected, conceptual understanding that you can seamlessly apply to completely unfamiliar contexts.
And this brilliantly illustrates the why behind the whole exam structure. Cambridge is intentionally targeting three distinct cognitive domains here: knowledge and understanding, application, and analysis. What does that mean for you? It means you literally cannot just memorize facts from a textbook and expect to get top marks. No way. You have to be able to actively analyze data and apply your knowledge to solve brand new problems in real time.
Now listen closely to this, because this is an examiner's secret we pulled directly from the principal examiner reports. If you want to achieve significantly higher marks, you need to reference cross-topic connections. The theoretical architecture of immediate addressing rests heavily on how it integrates with other areas of the syllabus. Top performers, they don't view these topics in isolation. They integrate them seamlessly, showing the examiner they understand the big picture.
Let's move right along to Section 2, Technical Methodology.
When you are interpreting data or writing algorithms, examiners demand a very specific, step-by-step procedural framework. It's like a recipe you have to follow. First, step-by-step decomposition of the problem. Break it down. Second, appropriate data structure selection. Third, efficient code implementation. And finally, rigorous testing. This algorithmic thinking process, think of it as your scalpel. You need to use it to carefully cut through those complex exam questions.
Notice the highly specific procedural flow required for actual exam execution. When you're in that seat, you must deconstruct the question, extract the relevant data, and this is especially true for things like binary representations, then select your analytical framework, and finally execute with incredibly clear notation and the correct terminology. This kind of systematic, step-by-step analysis is the absolute bedrock of evidence-based reasoning.
All right, now we're entering the danger zone. Section 3, Examiner Warnings and Alerts.
So what actually causes students to fail these specific questions? Well, the absolute first rule straight from the principal examiner reports is that you must define your terms clearly before you begin analyzing. It sounds simple, right? But candidates consistently confuse key terminology in extended responses. Listen, if your foundational definitions are shaky, your entire analysis is going to collapse in the eyes of the examiner.
You can really see the difference when you compare a vague answer with a context-specific one. Examiners are actively hunting for specific technical details rather than generic overviews. A vague answer might show, that you skimmed the textbook, but a context-specific answer, that proves you actually understand the underlying computer science principles at play in that exact scenario.
In fact, we've distilled the top 3 mistakes directly from those examiner reports. Number 1, vague answers lacking technical depth. Number 2, forgetting to check boundary conditions in edge cases. And number 3, providing answers that completely ignore the specific context of the question. Students constantly bleed marks by missing these exact points. Actually, a really great study trick here is to create an acronym out of these factors. Do that, and you'll ensure you check every single box during the pressure of the actual exam.
Okay, let's bring it home with Section 4, Evaluative Critical Analysis.
This is it. This is where we separate the good answers from the absolute top-tier responses required to secure those higher-order assessment marks. To evaluate algorithm quality effectively, you've got to identify and analyze trade-offs. It's a balancing act. You need to address time complexity and its performance impact, space complexity and memory usage, and exactly how edge cases affect boundary testing. Comparing these different approaches, that is exactly what Cambridge considers higher-order critical analysis.
So, what does the anatomy of a perfect answer look like? The exact evaluative thinking required to justify your recommendations involves evaluating your alternatives, considering multiple solutions, deeply analyzing those trade-offs we just talked about, acknowledging the limitations of your chosen method, and finally, justifying every single decision with hard evidence. You claim those highest marks by showing the examiner step by step exactly how you arrived at your conclusion.
So, as we wrap up this explainer, I want to leave you with this final, crucial thought. How are you going to apply the method mark strategy to your very next immediate addressing question? By mastering this surgical approach, by focusing on precise definitions, locking down algorithmic methodologies, dodging those common pitfalls, and deploying rigorous evaluative analysis, the question isn't whether you'll pass. No, the question is how you'll secure that final definitive academic edge. So get out there, practice those past paper questions with these specific frameworks in mind, and take absolute control of your results.